In the vast expanse of the cosmos, a symphony plays out, composed of stars and gas, light and shadow, birth. This cosmic symphony begins in the serene and delicate embrace of nebulae, clouds of dust and gas where the magic of star formation occurs. Here amidst the darkness lies the raw material of the universe, swirling and coalescing under the force of gravity. These vibrant clouds can be seen glowing in stunning hues, illuminating the cosmos with their ethereal beauty. Nebulae are not just beautiful, they are powerhouses of creation. Over millions of years, gravity pulls these particles together, gradually increasing pressure and temperature. This unseen force begins an extraordinary dance, leading to the birth of a new star. Imagine the wonders within these stellar nurseries as countless atoms collide and fuse, unlocking nuclear energy in a process akin to a cosmic fireworks display. It's here, at the heart of this formation, that hydrogen nuclei fuse to form helium, marking the dawn of a new celestial body. As new stars ignite, they begin their life cycle, each with its own destiny shaped by mass and environmental conditions. The most massive stars reach incredible sizes, shining brightly with intense energy. These giants, often thousands of times larger than our sun, burn through their nuclear fuel at an astonishing rate. Within just a few million years, they will exhaust their hydrogen supplies, and their once stable existence will spiral toward chaos. Yet, even in their dying moments, massive stars deliver one of the universe's most spectacular phenomena, the supernova. This cataclysmic event occurs when a star has reached the end of its life cycle and can no longer support its own gravitational weight. The core collapses, triggering a violent explosion that outshines entire galaxies for a brief moment. If you could witness a supernova from a safe distance, you would observe an explosion of unimaginable proportions, releasing more energy in a few days than our sun will emit throughout its entire lifetime. During this tremendous explosion, the star ejects its outer layers into space, enriching the surrounding nebula with heavy elements forged in its core. Elements such as carbon, nitrogen, and oxygen, fundamental building blocks of life, originate from these stellar explosions, scattering across the universe. This cosmic recycling is a poignant reminder that we owe our very existence to the dramatic life cycles of stars. The remnants left behind after a supernova can become neutron stars or black holes, depending on the mass of the original star. Neutron stars, incredibly dense and spinning rapidly, can emit beams of radiation that produce pulsar signals. This rhythmic ticking, like a galactic heartbeat, marks the remnants of a once mighty star. In contrast, the most massive stars vanish completely, their cores collapsing into regions in space where the gravitational pull is so strong that not even light can escape. Black holes, the enigmatic guardians of mystery. Amidst this relentless cycle of star birth and death, nebulae remain essential players, gathering new materials and preparing for the next generation of stars. It is a breathtaking cycle, one that plays out on a scale that challenges our understanding of time, space, and the very fabric of the universe. Each nebula pregnant with potential, each supernova a climactic finale, echoing the complex yet harmonious interplay of forces that governs the cosmos. As we delve deeper into this cosmic journey, we will explore the intricate details of how nebulae shape stars, and how these stars ultimately blaze brightly before transforming into remarkable supernovae. This unfolding narrative, from the gentle cradle of a nebula to the cataclysmic farewell of a supernova, is a story written in the stars, a testament to the grandeur of the universe and our place within it. Each moment of creation and destruction is a note in the grand symphony of existence, resonating across the vast void, waiting for us to listen. Picture a vast dark canvas scattered with an array of colorful brushstrokes. This is the universe, a magnificent masterpiece painted by forces beyond our comprehension. Within this cosmic artwork lies a key element of stellar creation, the nebula. But what exactly is a nebula? A nebula is a gigantic cloud of gas and dust in space, often described as the nursery of stars. These celestial structures are formed from remnants of dying stars, as well as from diffuse regions that contain the raw materials needed to create new stars and planetary system. You can think of a nebula as a creative workshop, filled with the ingredients that will eventually ignite to form blazing stars. Nebulae come in various types, each with its own unique characteristics. There are emission nebulae, which glow with vibrant colors due to the ionization of gas. The famous Orion Nebula, for example, is an emission nebula, lighting up the nighttime sky with a glow that can easily be seen from Earth. This glow is the result of radiation from young, hot stars within the nebula, heating the surrounding gas and dust, creating a dazzling spectacle. Then there are reflection nebulae, which do not emit their own light, but instead scatter the light of nearby stars. These nebulae often appear blue or white, a beautiful sight as they reflect the light from young stars embedded within them. The Pleiades, or the Seven Sisters, is home to such reflection nebulae, gently illuminating the night sky and captivating stargazers for centuries. Another type is the dark nebula, which acts as an obscuring cloud, absorbing and blocking the light from objects behind it. These dense regions of dust create shadows in the cosmos, often hiding the beauties of star formation within. The Horsehead Nebula, for example, is a striking dark nebula, resembling a horse's head, lying within the Orion constellation. Beyond their beauty, nebulae play an essential role in the life cycle of stars. Within their vast and nurturing environments, regions of higher density can collapse under their own gravity, eventually forming protostars. Imagine small pockets within the nebula where gas and dust clump together, gradually coalescing and heating up. This process takes millions of years and serves as the first significant step toward the birth of a star. As these protostars continue to gather more mass from their surroundings, they eventually reach a point where the temperature and pressure in their cores are sufficient for nuclear fusion to ignite. This is where the magic truly begins. A new star is born, shining brightly for billions of years and becoming a beacon in the cosmic landscape. But the journey doesn't end there. The gas and dust surrounding these young stars remain in the nebula, contributing to the ongoing cycle of star formation. This means that within a nebula, you can find different generations of stars all coexisting. Some stars are still in their formative stages and will take millions of years to fully develop, while others have already matured, providing the necessary light and heat for further star formation. The significance of nebulae extends beyond merely being stellar nurseries. They are vital for the enrichment of the universe. When massive stars exhaust their nuclear fuel, they explode in supernovae, dispersing elements formed during their lifetimes back into the surrounding nebulae. These elements, including carbon, oxygen, and nitrogen, are the building blocks of life itself. In this way, nebulae are not just places where stars are born, but also where the essential ingredients for life are forged and recycled. As we gaze at these celestial wonders, it is humbling to think of the profound cycles at play. The material that once formed our own sun is likely traceable back to a nebula that has undergone a similar journey, creating the very fabric of existence around us. In the grand tapestry of the universe, nebulae remain a reminder of the beauty of creation, the intersection of birth, life, and rebirth in the cosmos. As lush and intricate places of stellar development, they illustrate the intricate connections that bind us all to the stars. Exploring nebulae helps us appreciate not only their role in the universe, but also our place within it, as we share in the same cosmic story, crafted from the remnants of those ancient clouds. As we delve deeper into the cosmos, we arrive at a remarkable moment in stellar evolution: the birth of stars from the depths of nebulae. These vast clouds of gas and dust, primarily composed of hydrogen and helium, serve as the cradle for all stars. When regions within a nebula accumulate enough mass, the pull of gravity begins to dominate, causing these regions to collapse in on themselves. As the gas and dust spiral inward, they become denser and hotter, leading to the formation of what we call protostars. During this early phase, the temperature at the core of the protostar rises dramatically. It is here, at these extreme temperatures and pressures, that the process of nuclear fusion ignites. Fusion is the powerful reaction that occurs when lighter atomic nuclei, like those of hydrogen, merge to form heavier nuclei, such as helium. This reaction releases an enormous amount of energy, creating a balance between gravitational collapse and the outward pressure produced by these fusion reactions. The moment a protostar successfully commences nuclear fusion, it is officially classified as a star. But not all stars are born equal. The mass of the initial protostar primarily determines its future path. Massive stars, for example, may form from the gravitational collapse of dense regions containing enough material, while smaller stars, like our Sun, emerge from less dense regions. Massive stars evolve much quicker than their smaller counterparts. They burn their fuel at a much higher rate, leading them to shine brightly in the night sky, often as luminous blue giants. These stars live fast and die young, typically only lasting a few million years before exhausting their hydrogen and transitioning into more complex phases of fusion. As a star progresses through its life cycle, it undergoes a series of fascinating transformations. A mid-sized star, like our Sun, will eventually swell into a red giant once it has utilized most of its hydrogen. During this red giant phase, it will burn helium and other heavier elements created in its core. By contrast, the most massive stars can undergo fusion of elements up to iron. This brief but brilliant phase of stellar life is marked by a beautiful interplay of birthing heavier elements and releasing them into the cosmos. In stark contrast, smaller stars like our Sun gently shed their outer layers, creating stunning nebulae in a final act of beauty. These ejected materials enrich the nearby regions with the essential components necessary for new star formation, completing the cosmic cycle of life and death. Throughout the universe, the birth and death of stars play a crucial role in shaping the cosmos as we know it. The elements formed within stars, nurtured through nuclear fusion, are the building blocks of planets and life itself. When the most massive stars finally reach the end of their lives, they explode spectacularly in supernovae events, scattering these heavy elements far and wide into the universe. This process not only enriches the cosmic medium with new materials, but also triggers the formation of new stars and planetary systems. The life cycle of stars, transitioning from nebulae to nuclear furnaces, and ultimately leading to cataclysmic explosions, exemplifies the intricate tango of creation and destruction that defines our universe. Each star carries within it a legacy of those that came before, a poignant reminder of our interconnectedness with the cosmos. As we continue our exploration, the threads of this grand tapestry only grow more fascinating, beckoning us onward into the depths of space where new mysteries await. As we continue our journey through the universe, we find ourselves captivated by the intricate and astonishing life cycle of stars. Born from the swirling clouds of gas and dust within nebulae, stars embark on a remarkable journey, evolving through distinct stages that shape their essence and fate. In the early phase, a star resides in what we call the main sequence. This stage is the longest and most stable part of a star's life, often lasting billions of years. Here, the star engages in a delicate balance between the immense gravitational forces pulling it inward, and the pressure created by nuclear fusion reactions in its core. These reactions transform hydrogen into helium, releasing an astounding amount of energy. To put this into perspective, consider our Sun, a typical medium-sized star. It has been in the main sequence for approximately 4.6 billion years and is expected to continue shining steadily for several billion more. This phase epitomizes a star's maturity, radiating light and warmth, nurturing the celestial playground around it. As it ages, a star will inevitably exhaust its hydrogen fuel. The core contracts under gravity, raising temperatures and pressure until helium fusion ignites. The star swells, transforming into a red giant. During this period, it undergoes dramatic changes. For many stars, this is characterized by a notable increase in size and a change in color. Our Sun, when it enters this phase, will expand to engulf the inner planets, possibly even reaching the orbit of Earth. This expansion signifies an era of transformation, as the star prepares for the final stages of its existence. The internal processes during this time are extraordinarily complex. A red giant continues to fuse heavier elements, like carbon and oxygen, until it reaches a tipping point. Not all stars will take the same route through their life cycles. The mass of a star profoundly influences its evolution, determining how it will eventually meet its end. Low to medium mass stars, like our Sun, will shed their outer layers, creating beautiful planetary nebulae that beautifully encircle their remnants. What remains is the core, a dense, hot white dwarf, slowly cooling and fading over billions of years. In contrast, massive stars face a more cataclysmic fate. Once they have fused elements all the way to iron, they can no longer sustain nuclear fusion. The core collapses under its own immense gravity, leading to a rebound effect that results in a supernova explosion. This extraordinary event releases energy equivalent to that of billions of suns, briefly outshining entire galaxies and scattering the remnants of the star across the cosmos. The energy and matter expelled during a supernova is crucial for the formation of new stars and planets, enriching interstellar space with elements essential for life. Iron, carbon, and beyond, the building blocks of our very existence, are forged within the hearts of stars and released into the universe through these magnificent explosions. This process of death and rebirth exemplifies a cosmic cycle that is infinitely interconnected, weaving a tapestry of creation and destruction. Nebulae birthed from the remnants of earlier stars serve as stellar nurseries, where new generations of stars begin their own journeys. Our existence is intrinsically linked to these celestial phenomena, highlighting the beauty and interconnectedness of the universe. As we ponder the life cycle of stars, we are reminded of the elegance inherent in these cosmic processes. Each phase, whether it be the quiet stability of the main sequence, the dramatic transformation into a red giant, or the explosive finale of a supernova, contributes to the rich fabric of the cosmos. The cycle persists, an eternal dance of creation and destruction, offering wisdom and wonder as we witness the journey of stars and their profound impact on the universe. As stars reach the end of their life cycles, they embark on a final journey that varies dramatically based on their mass. This journey can lead to some truly fascinating and often beautiful endpoints that remind us of the complexity and mystery of the universe. For the smaller stars, those not much larger than our Sun, their conclusion is relatively gentle. After billions of years of nuclear fusion, these stars exhaust their hydrogen fuel. They expand into red giants, shedding their outer layers and leaving behind a dense core. This core is what we call a white dwarf, a stellar remnant that packs the mass of our Sun into a volume similar to that of Earth. A white dwarf is essentially the ember of a star, glowing faintly as it slowly cools over billions of years. Imagine this tiny yet remarkably dense object against the backdrop of a vast universe. This ember radiates light, but not through fusion. Instead, it glows from the residual heat of its past. As it cools, it will eventually fade into darkness over the course of trillions of years, becoming what we call a black dwarf. Although no black dwarfs are expected to exist yet in the universe's relatively young timeline. Now let's turn our attention to more massive stars, those at least 8 times the mass of the Sun. Their life stories take a more tumultuous turn. As these massive stars burn through their nuclear fuel, they create heavier elements in their cores. Elements like iron, which cannot generate energy through further fusion. Once the core's fuel is spent, the star undergoes a rapid collapse. The outer layers, unable to withstand the gravitational pull, follow inward at astonishing speeds. This collapse happens in mere seconds, unleashing unfathomable energy. When this happens, the star's core rebounds and explodes dramatically in a supernova. A phenomenal and catastrophic event that can outshine entire galaxies for a brief moment. But the aftermath of this explosion is equally captivating. In some cases, if the remnant core has enough mass, it can compress further to become a neutron star. This is a stellar body so dense that a sugar cube-sized amount of its material would weigh as much as a mountain. These incredibly dense objects are composed almost entirely of neutrons and can rotate at mind-boggling speeds, emitting beams of radiation that sweep across space, creating what we call pulsars. On the other hand, if the core's mass exceeds a certain limit known as the Tolman-Oppenheimer-Volkoff limit, it might continue upon another descent into gravity's grip, forming a black hole. This enigmatic object warps space around it and possesses a gravitational pull so intense that not even light can escape its grasp. Surrounding a black hole is the event horizon, often conceptualized as a point of no return. If any matter or light crosses this boundary, it is forever lost to the universe. Both neutron stars and black holes serve as fascinating examples of how nature can create wonders from destruction. They compel us to wrestle with profound ideas about reality itself, challenging our perceptions of time, space, and peace. This variety in stellar endings, the quiet glow of a white dwarf, the pulsating rhythm of a neutron star, or the enigmatic pull of a black hole, highlights the exciting diversity of outcomes determined by a star's initial mass. Each ending contributes to the grand cosmic cycle, wherein the life and death of stars give rise to the cosmic material from which new stars and perhaps life will emerge. As we continue this journey through the cosmos, let us ponder these remarkable transformations, which remind us that even in endings, there are new beginnings. In the vast expanse of the universe, every star tells a story, contributing to the intricate tapestry of creation. Each twinkling point of light in the night sky is a beacon of history, echoing the life cycles that have unfolded long before our time and will continue long after we are gone. As we shift our attention to the remarkable phenomenon of supernovae, we find ourselves on the cusp of one of the universe's most breathtaking spectacles. A supernova is not merely an explosion. It is a cataclysmic event that marks the end of a massive star's life and the birth of something entirely new. These stellar detonations can outshine entire galaxies for a short period, emitting an immense amount of energy, often equivalent to the sum of the star's energy output over its entire lifetime. Imagine a star, much more massive than our Sun, exhausting its nuclear fuel. As the internal pressures become unsustainable, gravity takes over, causing the star to collapse inward. This rapid contraction creates a core so dense and hot that it triggers a last-ditch effort to resist collapse through explosive nuclear fusion. In these final moments, the star expels its outer layers at staggering speeds of up to 30,000 kilometers per second. This catastrophic release of energy and matter transforms the star into a brilliant supernova, illuminating the cosmic tapestry with exquisite colors and light. Supernovae play a critical role in the grand architecture of the universe. As these explosions occur, they disperse heavy elements like carbon, oxygen, and iron into the surrounding interstellar medium. This elemental scattering is crucial, for it enriches the gas and dust clouds that will eventually form new stars and planets. Without the legacy of supernovae, the building blocks of life would be sparse. In a sense, each supernova is a celestial seed that contributes to the ongoing saga of cosmic evolution. Not all supernovae are created equal. There are two primary types, classified by their explosion mechanisms. Type I supernovae occur in binary star systems, where a white dwarf siphons material from its companion, until it reaches a critical mass and ignites in a thermonuclear explosion. Meanwhile, Type II supernovae arise from solitary massive stars, which exhaust their nuclear fuel and undergo core collapse, leading to a profoundly different type of explosion. Each variety provides astronomers with invaluable data to understand the universe's history and dynamics. The light emitted from a supernova is not only a sight to behold, but also serves as a valuable tool for modern astrophysics. By studying the light curves and spectra of supernovae, scientists can glean information about the universe's expansion and its rate. The most famous of these, Type Ia supernovae, have been used as standard candles to measure cosmic distances. Their consistent brightness allows astronomers to explore the far reaches of the universe, a pursuit that has revealed the existence of dark energy, driving the accelerated expansion of the cosmos. Yet, while they bless our night sky with their brilliance, supernovae also present a stark reminder of nature's relentless power. The shock waves generated by these explosions can trigger the formation of new stars, a process akin to cosmic recycling. Gas and dust, once part of a massive star, find new life in the birth of younger stars and planetary systems. This cycle of death and rebirth encapsulates the essence of the universe, a tapestry woven from countless threads of creation and destruction. Visualize a supernova as it lights up the cosmic canvas. For days or even weeks, these explosions can outshine entire galaxies. Observers on Earth, gazing up into the night sky, may witness these stellar displays as fleeting exclamation points, whispering stories of cosmic evolution. The first supernova observed in recorded history, Sin 1066, lit up the sky for a month, marking a historical moment that captivated human imagination. In many ways, supernovae are both endings and beginnings. The remnants left behind, known as supernova remnants, may coalesce into new structures, such as neutron stars or black holes. Our understanding of these phenomena deepens our connection to the universe, drawing us closer to the stars that birthed the very atoms of our existence. As we reflect on the beauty of supernovae, we realize they serve a dual purpose, illuminating our skies and fueling the creation of new cosmic wonders. This delicate balance is a metaphor for the universe itself, where chaos and order coexist in a harmonious dance, reminding us that every end is but a prelude to a new beginning. As we delve deeper into the cosmic dance between nebulae and supernovae, it's crucial to appreciate how intricately these phenomena are woven into the fabric of our universe. At the heart of this connection lies the concept of stellar evolution, a process that not only shapes individual stars, but also transforms entire regions of space and time. Nebulae, the stunning clouds of gas and dust that cradle the beginnings of stars, hold the secrets of creation. They are not merely a backdrop, They are vibrant nurseries where matter coalesces under the gentle pull of gravity. As clumps of gas become dense enough, they ignite the stellar birth process, transforming a nebula into a protostar. This moment is both a beginning and a promise, an assurance that within this swirling mass lies the potential for extraordinary life. As stars emerge from their cloudy cocoons, they enter a majestic phase of burning bright. What follows is a fascinating journey through various life stages, marked by fusion reactions that forge heavier elements. Stars like our Sun will unfold over billions of years, gracefully aging as they maintain a delicate balance between gravitational collapse and outward thermal pressure. Meanwhile, more massive stars follow a different trajectory. Their lives burn more rapidly, often lasting only a few million years. In this race against time, they undergo a series of explosive transformations, ultimately culminating in a spectacular finale. When a massive star reaches the end of its life, it undergoes an extraordinary change, a supernova explosion. This event is one of the universe's grandest spectacles, releasing energy equivalent to that of millions of suns in just a few days. Imagine the energy released by a single drop of water compared to the vast oceans. Such is the power of a supernova, transforming the landscape of the universe forever. In an instant, the core collapses under gravity, while the outer layers are expelled, scattering essential elements across the cosmos. Carbon, oxygen, iron. These are but a few of the vital building blocks of the universe, forged in stellar cores and released into the void. The enriching legacy left by supernovae is staggering. After the explosion, the remnants pave the way for future generations of stars and planets, create new nebulae filled with the materials necessary for the next chapter of cosmic creation. This is where the cycle comes full circle. Every cycle of stellar birth and death contributes to the vast canvas of the universe, painting it with brighter shades of existence. To illustrate this symbiotic relationship, consider this: our own planet, Earth, along with everything on it, is made of stardust. These fundamental elements, which emerged from the interiors of ancient stars and were scattered by supernovae, coalesce to form new worlds. It's a profound thought. Our existence is intimately tied to these cosmic events. Every nebula that swirls in the depths of space has the potential to ignite new stars, while every supernova contributes to the continuous cycle of matter in the universe. They remind us that destruction is not the end, but rather a transformative process leading to renewal. Such is the nature of the cosmos, a magnificent interplay of creation and annihilation, where one star's death is another's genesis. As we gaze upward into the night sky, it is easy to be mesmerized by the flickering lights of distant stars. However, those twinkling points represent countless stories of birth, life, and death. Each one, whether a nebula or a supernova, is a chapter in an ongoing narrative, an epic tale of interstellar connection that has played out over billions of years. In this grand tapestry, we discover that our universe thrives on the cycle of life and death. From the formations of nebulae, where stars begin their journey, to the brilliant flames of supernovae that usher in new beginnings, we uncover a profound truth. Every stellar life contributes to a cosmic continuum, ever enriching and evolving. As we ponder our place within this vast expanse, we begin to feel the pulse of the universe, a beautiful reminder of our shared origins and our ever-present connection to the stars. As we drift gently towards the conclusion of our journey through the cosmos, let us take a moment to reflect on the profound life cycle of stars and how this narrative weaves together the fabric of our universe. Stars are not just distant points of light. They are the architects of cosmic evolution. From the swirling clouds of gas and dust in nebulae, where intricate cosmic chemistry begins its dance, to the cataclysmic finale of supernova explosions. The existence of stars offers a continual reminder of both creation and destruction. Imagine drifting through a vibrant, glowing nebula, where the very building blocks of life are forming amidst swirling colors of pink, blue, and gold. These nebulae are not merely beautiful spectacles. They are the cosmic wombs from which new stars are born. As gravity pulls particles ever closer together, igniting nuclear fusion at their cores, we witness the birth of celestial giants. Magnificent stars emerge, each with their own unique path and destiny, adding to the rich tapestry of the universe. As these stars burn bright with their energy, they illuminate not just the night sky, but also the potential for life. Over millions of years, they evolving through the stages of their life cycles. They grow, expand, and often form planetary systems, habitats where life may one day flourish. This transformation further demonstrates their role as guardians of the cosmos, nurturing the elements that become the very foundation of planets. Even the Earth we inhabit is composed of materials originally forged in the hearts of ancient stars. But the story of a star does not end with its brilliance. Eventually, even the most majestic stars must succumb to the inevitable pull of time. When they exhaust their nuclear fuel, a striking transformation occurs. Massive stars collapse within themselves, leading to spectacular supernova explosions that scatter stellar remnants across the cosmos. This scattering creates new nebulae, initiating the cycle all over again. Through these awe-inspiring deaths, heavier elements formed in the fiery cores, elements like carbon, oxygen, and iron, are dispersed into space, enriching the surrounding cosmic nursery. Consider for a moment the significance of this cycle. The idea that the atoms in your body were once forged in the heart of a dying star is nothing short of incredible. It connects us to the universe in a profoundly intimate way. From the very beginning of time, the death of one star paves the way for the birth of another, cultivating a continuum that nourishes life. As we pause to reflect on our place within this grand narrative, let us remember that every gaze at the night sky connects us to this cycle of being. Each star we see overhead is a testament to resilience, change, and the ever-present potential for new beginnings. It serves as a gentle reminder of our own existence and journey through the universe, where we too are shaped by the forces of creation and destruction. In this vast expanse of space and time, we are both infinitesimal and integral, part of a story that transcends our own lives. So, the next time you look up at the stars, take a moment to marvel at the wonders of the cosmos. Recognize the legacy of those stars that have come before and understand the potential of those yet to be born. As you lay your head down, drifting off into slumber or finding solace in thoughts of the universe, remember that you are a part of this magnificent cycle. The stars are not just distant celestial bodies. They are a part of you, as much as you are part of them. If you found beauty and peace in this journey through the universe, consider following our channel for more explorations into the wonders of the cosmos. Like and share this video, and invite others to marvel at the stars, reminding us all of our connection to the infinite sky above.